In this video, we'll be solving a quadratic inequality. A quadratic inequality is an inequality that can be written as ax squared plus bx plus c is less than 0. Or we could have any other inequality symbol here. Now what I'll do is I'll write out the steps for solving a quadratic inequality on the left side here. And then I'll actually do those steps on this quadratic inequality on the right. My first step is to solve the corresponding quadratic equation. So we need to solve 3x squared minus 11x minus 4 equals 0. Now I'm just going to use the quadratic formula on this. We can see that a is 3, b is negative 11, and c is negative 4. Our quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So let me fill these values in for a, b, and c. X is equal to a negative. My b is negative 11 plus or minus the square root of b squared is 121 minus 4 times 3 times negative 4 all over 2 times 3. This is negative is positive, so 11 plus or minus, we need to do this multiplication back here first, so 121 plus, and then 12 times 4, 48, all over 6. And this is 11 plus or minus the square root of 169 over 6. So this is 11 plus or minus 13 over 6. So we have x is equal to 11 plus 13 is 24. 24 over 6 is 4. And 11 minus 13 is negative 2. Negative 2 over 6 is negative 1/3. My next step is to identify the intervals determined by the solutions of the quadratic equation. So let me draw a number line so we can see our intervals. Our numbers are 4 and negative 1/3, so I'll put negative 1/3 here and 4 here. So one of the intervals is all numbers that are less than negative 1/3. Another interval we need to consider is the interval between negative 1/3 and 4. And then the last interval is numbers that are greater than 4. Now we need to use a test value from each interval to determine which intervals form the solution set. So a test value is any number that's in this interval, and if we work out the problem with that test value, then all of the numbers in that interval behave the same way. So I want numbers that are less than negative 1/3. Let's pick a test value of negative 1. And then for this interval, I want numbers between negative 1/3 and 4. I'll pick 0 for my test value. And then for numbers greater than 4, let me pick 5. So I need to check each of these numbers in this inequality. So let me copy that down here. 3x squared minus 11x minus 4 is greater than 0. All right, I need to check each of these test values to see if they work or not. So let's do our test value of -1 first. So I have 3 times -1 squared minus 11 times -1 minus 4, and I want to see if that's greater than 0. This is 3 plus 11 minus 4. This is 10, which is greater than 0. So yes, the interval with the test value of -1 does work. Now let's test the interval with the test value of 0. Test value equals 0. So we have 3 times 0 squared minus 11 times 0 minus 4, and we want to know if that's greater than 0. 0 minus 0 minus 4. -4 is not greater than 0. So this one is no. That interval does not work. And then we need to test the test value 5. Test value equal 5. We have 3 times 5 squared minus 11 times 5 minus 4, and we want to see if that's greater than 0. So 3 times 25 is 75 minus 55 minus 4, and this is 16, and that is greater than 0. So yes, that interval does work. So now we need to write our solutions. The test interval of -1 worked, so we want all of the numbers that are less than -1/3. So one way to show a solution for an inequality is with a graph. So let me draw my points in here. -1/3 and 4 were the boundaries. And I said that this interval works. So I'll be shading those numbers in. And I also know that the interval with the test value of 5 works. So that's numbers greater than 4. That's these. Now my inequality was strictly greater than. There was not a little line under the inequality symbol. So when it's strictly greater than or strictly less than, you don't include your boundaries. So my boundary points are not included in the solution, and I have to use a parentheses to show that they're not included. So this is the graph. Now you may be asked to show your solution in interval notation. And interval notation would look like -infinity up to a -1/3. Union with the set from 4 to +infinity. And then another way to show it would be set notation. So if we wanted to show our solution with set notation, we would say the set of all x's such that x is less than a -1/3 or x is greater than 4. So these are ways to show our solution for this inequality.